Using a single 12/3 cable to wire two circuits is not permitted by the National Electrical Code. Each circuit requires its own set of wires. To safely and code-compliantly wire bathrooms, firstly, disconnect the existing 12/3 wire that is feeding both bathrooms. Secondly, run separate 12/2 non-metallic cables, often called Romex, from the breaker box to each individual bathroom. Thirdly, connect these new wires to new electrical outlets and light fixtures located within each bathroom. Within the circuit breaker panel, firstly, install two single-pole circuit breakers, allocating one for each separate bathroom circuit. Secondly, as an added measure of safety, the option exists to install a double-pole circuit breaker, offering simultaneous protection for both of the bathroom circuits. When it comes to the outlet connections, consider the following. For bathroom number 1's outlet, connect the black wire coming from the new 12/2 cable to the brass screw located in the outlet. Next, connect the white wire to the silver screw. Finally, connect the bare ground wire to the green or bare copper screw. Repeat these same steps outlined above for the second bathroom's outlet. It is crucial that all electrical work is carried out by a licensed electrician to ensure compliance with code requirements and adherence to established safety standards. It is also important to verify that the local building codes align seamlessly with the NEC to eliminate any potential inconsistencies. The integrity of electrical installations hinges on adherence to safety protocols and code regulations. The National Electrical Code, or NEC, serves as the cornerstone for electrical safety in the United States. It provides comprehensive guidelines for electrical installations, ensuring the safety of people and property. Electrical wiring is a crucial aspect of any building, and it is vital to understand the code requirements for safe and compliant installations. One common question that arises is whether it is permissible to use a single 12/3 cable to wire two separate circuits. According to the NEC, this practice is generally not allowed. Each circuit should have its own dedicated set of wires to ensure proper functionality and safety. A 12/3 cable contains three conductors: a black wire, a white wire, and a bare ground wire. While it may seem convenient to use this cable for two circuits, it can lead to several problems. Firstly, it can overload the neutral conductor. In a multi-wire branch circuit, the neutral conductor carries the unbalanced current from the two hot conductors. If the neutral is shared between two circuits, it can become overloaded, especially if both circuits are heavily loaded. This can result in overheating, insulation damage, and even fire hazards. Secondly, using a single 12/3 cable for two circuits can create confusion and safety issues during maintenance or repairs. It can be difficult to identify which circuit is connected to which device, making it challenging to troubleshoot problems or perform modifications. Additionally, if one circuit trips due to an overload or fault, it can affect the other circuit, potentially causing unexpected outages or equipment damage. To ensure safe and code-compliant wiring, it is recommended to run separate 12/2 non-metallic cables, or Romex, from the breaker box to each circuit. A 12/2 cable contains two conductors: a black wire, a white wire, and a bare ground wire. By using separate cables for each circuit, you can avoid overloading the neutral conductor, simplify maintenance, and improve overall safety. When installing the new wires, it is important to follow the NEC guidelines for conductor sizing, overcurrent protection, and grounding. The size of the conductors should be appropriate for the ampacity of the circuit. For example, a 15-amp circuit should use 14 American wire gauge copper conductors, while a 20-amp circuit should use 12 American wire gauge copper conductors. The overcurrent protection device, such as a circuit breaker or fuse, should be sized to protect the conductors from overloads and short circuits. The grounding system should be properly installed to provide a low impedance path for fault currents, reducing the risk of electric shock. In addition to the general wiring requirements, there are also specific rules for wiring bathrooms. Bathrooms are considered wet locations, and they require special precautions to prevent electrical hazards. One important requirement is the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small imbalances in the current flow and quickly de-energize the circuit, protecting people from electric shock. The NEC requires GFCIs to be installed in all bathroom receptacles, as well as any other locations where water is present, such as kitchens, laundry rooms, and outdoor areas. Another requirement for bathroom wiring is the use of arc fault circuit interrupters, RFCIs. RFCIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. The NEC requires RFCIs to be installed in all branch circuits that supply receptacles and dwelling units, including bathrooms. RFCIs can help prevent fires by detecting arc faults and energizing the circuit before a fire can start. When wiring bathroom outlets, it is important to follow the correct polarity. The black wire or hot wire should be connected to the brass screw on the outlet, while the white wire or neutral wire should be connected to the silver screw. The bare ground wire should be connected to the green or bare copper screw. Correct polarity is essential for the proper operation of electrical devices and to prevent electric shock. It is also important to ensure that all electrical connections are tight and secure. Loose connections can cause overheating, arcing, and even fires. Use appropriate tools, such as wire strippers and screwdrivers, to make secure connections. After completing the wiring, it is important to test the circuits to ensure that they are working properly. Use a multimeter or circuit tester to check for proper voltage, continuity, and grounding. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the wiring. The electricians have the knowledge, skills, and experience to safely and code-compliantly wire your home. They can also identify any potential hazards and provide solutions to ensure the safety of your electrical system. In summary, using a single 12/3 cable to wire two circuits is generally not allowed by the NEC. Each circuit should have its own dedicated set of wires to ensure proper functionality and safety. When wiring bathrooms, it is important to follow the NEC guidelines for conductor sizing, overcurrent protection, grounding, GFCIs, and RFCIs. Correct polarity and secure connections are also essential. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the wiring. Here are some additional considerations for wiring bathrooms. Firstly, consider the location of the outlets. The NEC specifies the minimum number and placement of receptacles in bathrooms. Generally, there should be at least one receptacle within 36 inches of the outside edge of each lavatory basin. The receptacle should be located on a wall adjacent to the basin, not on the countertop. Secondly, choose the right type of outlet. In bathrooms, it is recommended to use tamper-resistant receptacles to protect children from inserting objects into the outlets. Tamper-resistant receptacles have internal shutters that prevent foreign objects from being inserted unless a plug is inserted. Thirdly, consider the lighting. Bathrooms require adequate lighting for safety and functionality. Install recessed lighting, vanity lighting, and or a ceiling-mounted fixture to provide sufficient illumination. Make sure the lighting fixtures are rated for wet locations if they are installed near water sources. Fourthly, plan for future needs. When wiring bathrooms, it is a good idea to plan for future needs. Consider adding extra circuits or outlets for potential additions, such as a whirlpool tub, a heated towel rack, or a bidet. This can save you time and money in the long run. Fifthly, label the circuits. After completing the wiring, label each circuit breaker and the PAL to indicate which circuit it controls. This will make it easier to identify and troubleshoot problems in the future. Sixthly, document the wiring. Keep a record of the wiring layout, including the location of outlets, switches, and lighting fixtures. This documentation can be helpful for future maintenance or modifications. Seventhly, stay updated with the NEC. The NEC is updated every 3 years, so it is important to stay informed of the latest changes and requirements. Consult with a qualified electrician or electrical inspector to ensure that your wiring complies with the current code. By following these guidelines, you can ensure that your bathroom wiring is safe, code compliant, and functional. Remember, electrical work can be dangerous, so it is always best to hire a qualified electrician if you are not comfortable working with electricity. Understanding the NEC requirements for electrical wiring is crucial for ensuring the safety of people and property. By following the code guidelines and best practices, you can minimize the risk of electrical hazards and create a safe and functional electrical system. It is crucial to underscore the significance of professional expertise when undertaking electrical work. Electricians undergo extensive training and possess the requisite knowledge to navigate the complexities of electrical systems safely and effectively. Attempting electrical projects without proper training can lead to hazardous situations, potentially causing severe injuries, property damage, or even fatalities. Engaging a licensed electrician ensures adherence to safety protocols, compliance with local codes, and the implementation of industry best practices. They conduct thorough assessments, identify potential risks, and execute installations with precision and care. Furthermore, licensed electricians provide warranties and guarantees for their work, offering peace of mind and protection against future issues. Entrusting electrical work to qualified professionals is an investment in safety, reliability, and the long-term integrity of your property. Remember that electrical safety is paramount, and it is never worth taking shortcuts or attempting to save money by doing it yourself without the necessary skills and knowledge. Another vital aspect of electrical safety is regular maintenance and inspection of electrical systems. Over time, electrical components can degrade, connections can loosen, and insulation can deteriorate, increasing the risk of electrical hazards. Regular inspections by a qualified electrician can identify these issues early on, allowing for timely repairs and preventing potential problems from escalating. Maintenance tasks such as tightening connections, replacing worn-out components, and testing safety devices can help ensure the continued safe operation of your electrical system. It is also important to be aware of the signs of electrical problems, such as flickering lights, warm outlets, burning smells, or tripped circuit breakers. If you notice any of these issues, it is crucial to investigate them promptly and consult with an electrician if necessary. Ignoring electrical problems can lead to more serious consequences, such as electrical fires or electrocution. In addition to regular maintenance and inspections, it is important to practice electrical safety in your daily life. Avoid overloading circuits by plugging too many devices into a single outlet or extension cord. Use surge protectors to protect sensitive electronic equipment from power surges. Keep electrical cords away from water and heat sources. Never attempt to repair electrical appliances or equipment unless you are qualified to do so. Teach children about electrical safety and keep them away from electrical hazards. By following these simple precautions, you can significantly reduce the risk of electrical accidents in your home. Finally, it is important to remember that electrical codes and regulations are constantly evolving to reflect new technologies and safety concerns. Stay informed of the latest changes to the NEC and other relevant codes by consulting with a qualified electrician or electrical inspector. Attend training courses or workshops to update your knowledge and skills. By staying up to date with the latest electrical codes and regulations, you can ensure that your electrical work is always safe, compliant, and in accordance with industry best practices. In conclusion, electrical safety is a shared responsibility that requires knowledge, diligence, and a commitment to following established guidelines. By understanding the NEC requirements, practicing safe electrical habits, and seeking professional assistance when needed, you can create a safe and functional electrical system for your home or business.